Okay, so I guess we're ready to go. Welcome everybody to the mid-month main meeting. And before we get started, I'm going to read the disclaimer. Please note that all our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood that you have accepted these terms. And that out of the way. So tonight we've got scheduled. Michael is going to present on antenna modeling, and then after that, we'll have like questions, suggestions afterwards, and whatever else comes up. Ready to go, Michael?
Yep, I am. Yep. I just got to figure out how to share now. There's the share. I guess I go entire screen. No, that didn't work. I want window. This is what I want, I think. Okay, can you see that? Can everybody see that?
Not yet.
Really? Why didn't it share?
I can see it. I saw it.
All right, let me go back to, where is it? Here. Try again. Okay, so I presume I would share the window. Or maybe the entire screen, I don't know. That's not right.
Share the screen. That seems to work the most of the time.
Okay, well, that's what I'm doing now.
Share the screen. When you click on share the screen, then click on the screen.
Okay. And then click share.
And then click share. There you go.
There you go.
Okay, good. All right.
That's good.
Okay. Let me see. Okay, so this is the full screen, right? And it looks like it works. Okay. So the reason I'm doing this is I bought a 40-meter mast with the idea that I would set up with my QCX transceiver and take it camping and set it up and be able to look at the antenna, and I wanted to model it as well to just decide what kind of antenna I wanted to put up. And Ed, the VA3 TPV, and Paul Egan, VA3ZC, helped me do this. So anyway, so that's the genesis of this thing. Yeah, I'm going to talk about 4NEC2, which is a modeling program to model this antenna, which is a vertical with two elevated radials. Talk a little bit about the construction and a little bit about the common mode choke and some tests I did. So 4NEC is a pretty powerful antenna modeling program. It's based on the NEC engine. I think that's right. And I start out by saying I am not an expert in this stuff, so any mistakes I make are my own. But anyway, you can use it to model many different types of antennas. Like you can model the ground you've got. You can model the load types. You can put capacitors and inductors and coils into an antenna. You can model a transmission line, which I have not done here, by the way. You can also model the effect of conductor insulation, like the insulation on the wires you use, and so on. You can also optimize the design, which is really handy, as I'll show you. So what I wanted to do was design a 40-meter antenna that could take camping, and I also had limited space in the campsite. So I also wanted to be able to put it in my backyard to check it out and make sure it worked. And I'm using a 40-meter QCX transceiver, which is only good for 5 watts. Well, it puts out 5 watts. It's a single band transceiver as well. And I have to add that mine works. Daniel will understand that. I used a lightweight wire because the mast is 40 feet long, and I wanted to get the vertical up high, the full length of it. And so I used number 22 stranded wire for the antenna and the radials, and I used RG316 coaxial cable, which is the really small stuff. It didn't really matter here because the feed line is on the ground, whereas if I wanted to make this a dipole, or some kind of dipole, then I would have had to get the feed line up to the top, and that's the reason to use small stuff, RG316. Technically, it's an asymmetrically hatted vertical dipole. That's all I'm going to say about that, since I really don't know the details. It has one vertical and two radials, and they're all roughly a quarter wavelength long. And like I say, Ed and Paul helped me do the design. So it's 40 meter. It's a 40 meter single band. It puts out about 5 watts, supposedly. There's about 1 watt loss in the cable. I measured that at one point, so that means what's getting to the antenna is 4, maybe, if it's properly matched. And the QCX doesn't have 250 ohms, and the QCX doesn't have an internal tuner, so it's really important to resonate it to get it at the right resonant frequency. And also, you have to use a common mode choke to get anything radiation off the feed line, outside of the feed line. So, excuse me, this is what 4NEC looks like. I'm gonna show presenter screen. That's not what I wanted. Oops, how do I get back out of this? I don't know how to get out of it. It doesn't, maybe I can only see it. Hey?
Try escape.
Good idea. Escape. Okay, it's gone. Right. What I was looking for was, I don't see it here. Where is the?
You're out of presentation mode.
Are you?
Yeah, that's right. That's why I'm not seeing it. Okay. Let me try now. Pointer options. That's what I wanted. Okay. So carrying on here. Yeah. So it doesn't have an internal tuner and whatnot, so you got to be careful. So this is the main window you're looking at when you look at 4NEC2, how it starts up. And among other things, you've got you can look at the input and output settings. You can tell it what to calculate. You can draw a 3D representation of the antenna radiation pattern and so on. And these are just all the parameters that are in the model. This one I ended up with 48.4 ohms, which I thought was pretty good, and SWR 1.03 and an efficiency of 92%. That's apparently that's what the model says. So I don't know. So NEC2 has a number of things. When you set it up and you go to the input mode, you get a number of tables that you use to fill out to basically tell the program what the antenna is. And you can do things like use variables. So the wire radius is, and this is in feet, by the way. So the wire radius of number 12 is 0.00138. There's a coding radius that you have on the wire as well. It's 3 feet. The antenna is 3 feet off the ground. And it's got 1 meter rather. And it's got the vertical length is 33.7 feet. And the radials on each side, each radial is 11.9 feet. So it's quite small, which is good because it means you can use it in a small space. You have to tell the program how many segments there are in each of the wires. And this is for calculation purposes. So for a long wire, for a long distance, you can use a fair number than like 20. For a smaller one, like the radials are shorter, so I use nine segments. And that's got to do with how it calculates stuff. And this is a symbols table, so you can tell the program what the lengths are rather than putting them in the model directly. Then there's a geometry table. There's this one here. There's a source load table and a frequency table. So this is how you set the thing up. So this is my antenna. The vertical is 33 feet. The radials are 13 feet each side. And there's a coil, 25 microhenry coil to shorten the radials. Otherwise, they ought to be 30 odd feet long. And it's 3 feet off the ground. So this is a geometry where you tell it in a 3-dimensional plane, X, Y, and Z coordinates, where the pieces are. So there's 3 wires, the vertical one and the 2 radials. So you tell it that. And you tell it where, the orientation, X, Y, Z, or whatever it happens to be. And this table, this is another table that you can set up that gives you the frequency. You tell it the frequency, 7 megahertz in this case. You tell it what type of ground it is, and there's water, there's excellent ground, there's pastoral field ground, all kinds of stuff, and the environment it's in and whatnot. Average environment. This is ground type average. You really have no idea what to put here, so you put average. At least I did. And then there's the source and load table. This is the excitation, which is 10 volts at real and no imaginary part, magnitude 10. And then there's this load table. And this is where you tell it, the first 2 lines here are the coil, and it's 25 microhenry coil. And it's the program considers it to be an RLC circuit. So it calculates for you, well, you tell it parallel RLC. So it calculates, given the 25 microhenries, it comes up with the resistance in ohms. So I didn't do that. The program just calculates it. And the wires are all copper, and it tells you the coating, which is PVC. And there's the radius of the wire. So you tell it all that stuff, and it produces a model for you. Shows you the model. Here's the vertical piece, the coil, the red square, or the blue squares rather, the coils. This is the source. It shows it this way, the X, Y, and Z axis as well. So then you generate a frequency sweep, which starts the process, and you tell it the start and stop frequencies you want to run and whatnot. And then it comes up with this. This is the original, this piece here on the left is the original table I was showing you earlier. This is the SWR. This is a modeled SWR, not necessarily what you actually get. And this came out with one SWR1, more or less, at 1.03 it was, at 7.05, which was my target frequency. And this is the reflection coefficient, which is pretty good at -35. And this is a cross section of the antenna. The vertical axis is here, so the vertical antenna is here. So it tells you it's got nice lobes around it. And then you can this is the one I went the wrong way, I think. Yeah. Then you can get a 3D representation of the antenna, and the red is the maximum gain, and it's symmetrical, so it's it's the same in all 3 directions, all directions around it. And if it was a Yagi, it would look different. And then you can do things like optimize it. The vertical length started out at 13, or the radial length started out at 11 feet each one. And you can, 13 feet. And then you can set it up and you can go through this, you can get it to optimize things. And what it's doing here, it's optimizing on the SWR. So it's looking to get the best of the SWR. And what it does, it chunks through the lengths. You can see the lengths go from 13 to 12 to down to 11.9 feet. So that you do that, and now you've got a model that should work for you. And this is the radial lengths now. So before I did this, the resonant frequency is around 6.6 or 6.8 or something, way down here. The curve went way down here to the left. And once you optimize it, it changes the length for you to a better length, and you get back to where you were with this acceptable SWR. So that's what I did. So what I actually did, I built the antenna this way with I left the length at 33.8 feet, I think it was, 33 feet 9 inches, and I adjusted the radial length to 11, almost 12 feet to start with. And then when you actually do it, you actually set up your model. Oh, this is the gain looking from the side again. When you actually do it and set up your antenna, the real antenna, it doesn't work quite that way, the lengths. So this is the antenna. The top, this is the vertical element number 22 insulated wire. This is the coil. It's 20 or 30 turns, I forget now, on a piece of central vacuum pipe, actually, PVC pipe, and just wrap it around. And the final version, I taped it with proper electrical tape. This is the just a piece of plexiglass I had lying around, and the connectors in here. The vertical goes out that way, and the radials are connected to the shield part of it. And this is the common mode choke. Antenna gets connected here, or the QCX gets connected there, rather. So why do you need a CMC, a common mode choke? And that's all about eliminating it. Ideally, it would be a balanced antenna. This one isn't, because it's not balanced at all. But in a dipole, for example, if it was an ideal dipole, a reasonable length up in the air, ideally there would be, each leg of the dipole would have no current, so they'd have the same current exactly. So there'd be, all the current would come up the center of the coax, go down the inside. The return current from the other side of the antenna would go down the inside of the coax to the receiver. So there'd be no transmitter or receiver. So there'd be no unbalance. And the common mode choke is all about getting rid of that, any imbalances there are. So this is my common mode choke based on something that Ed Spingola did. It's two binocular cores, and the mix is 31. These are Palomar engineering cores, and the ferrite mix, they're ferrite cores, and the mix is number 31, which is what's recommended for the lower end of the HF band. This is the RG316. It's wound, there's 4 turns here, in and out 4 times, and it comes in on one side, goes out on the other. So that's the choke. This is the coil. Like I said, it's made of central vacuum pipe. And there's the tape around the side to hold it in place. And this is the telescoping mast I used. I got this design from Don McPhee, VA3BOW, for the mast support. This is nothing more than a piece of drain pipe, and it's held in by the guy ropes things here, and with these are pipe clamps to hold the rope in place so you can get it straight. You can put this together really quickly yourself. And this is the 40-foot mast collapsed. I got it from Vibrotex. It's a spider beam mast, and it's telescoping. And on the top, you can't see it here, but on the top there's an eye bolt inside on the top element. So basically, you just pull the pieces up, twist them, and they lock into place. So this is what the mast looked like. This is in a campground. Ken will know this is Earl Rowe, Ken, by the way. There's the antenna fully extended, the mast, and here's the antenna with the coils. There's one radial here, another radial over there with the coils, and they're 3 feet off the ground, more or less. What you have to do is you measure with your network analyzer, your mini VNA, you measure the resonant point. You take a look at it, and you adjust the lengths accordingly, and you take a couple of inches off or add a couple inches to the outside, this radial here and that one over there, and you adjust these to get the right resonant frequency. Takes a bit of time, but you end up with this. This is the Nano VNA Saver program that runs with a mini VNA. And this is it's a nice smooth curve, and it says that the minimum SWR is down here, and the green marker here is 1.124. And this is what was actually set up. So this actually works. You tell it the frequency range you want to look at and all that stuff. So this is what I actually ended up with. I was pretty pleased with that. And so now you've got the antenna set up, how do you know it works? Well, you can use the reverse beacon network, where you basically call CQ. in CW because it's the QCX is CW. You call CQ a couple of times, and after a little bit, you get this, and you monitor the reverse beacon network. And what you see here is this is me. These are the guys that spotted me from their monitoring stations, and these are the distances. Well, the closest one was north of Algonquin Park. We're around just north of Algonquin Park here. Got out to Chicago, Washington, New York, Boston area. So I was pretty happy with that. And the range is from 130 miles, one of them was, and the other one was 439. So that shows the antenna worked, which is what it should have done. And that's all I have to say. I think that's the end. Yeah, that's the end. Any questions before I shut this thing down?
Go ahead, Pete.
Thanks, Michael. I did play with the EasyNet a long time ago and forgotten everything, of course, of it. But one thing I wasn't sure, did you have an antenna plans already in front of you, and you entered all those dimensions of the various wires, et cetera, and the coil values and all that kind of stuff into EasyNet, and then let it spit out and then fine tune there?
Yeah, I knew what I wanted. I knew what I wanted to do. I had with Ed and Paul, we designed the antenna, so I knew what I was putting up, and I modeled it first on 4NEC2 to see what I got, and it looked pretty good. So then that's where all the information that went into those tables, that's where it came from, the length, based on what it actually was going to do. And I set it up in the backyard the first time, and it came out pretty well. So, and I've got trees all around, and at the campground, there's more space around, but still much the same. Yeah.
Is there a function in that program where you could just say, this is what I want, and then it'll spit out the dimensions of what you're supposed to have?
No, I don't think so. You have to put in.
You need to put in those. Okay.
You have to put the stuff in, all the stuff, all these table things. You have to put them in because you're telling the program what you're doing. So for a dipole, it's 2 wires, whatever distance up.
Yeah. Okay. And how accurate did you find for NEC2 compared to your real world, what the VNA was telling you? Like when you did your last measurements and ran for NEC2, it spat out, this is going to be the impedance and the SWR. And then I assume you then ran the VNA with that setup outside in the real world.
Yeah.
What was those comparisons like?
Well, the actual model came up with this 7.05 as the resonant frequency because I'd asked it to do that.
Yeah.
And I had optimized the lengths. So what I actually built was what the program told me to build. And when I put it up the first time, it was the resonant frequency was too high. It was more like 7.15, 7.8, or 7.2 almost, so 7.15 roughly. So then I had to adjust it. That's what I actually saw when I put it up the first time. And then I pruned the lengths down to where I wanted to get to the actual results I got.
Okay.
So you have to you start with what you think is right, and then you adjust. Then you look at it in real life with the mini VNA, and then your SWR is not, the resonant frequency is not where you want it to be. So if it's too low, then you shorten the radial lengths, and if it's too high, you lengthen them. And the only thing you have to play with really is the outer half of each of the radials in this case. And I was taking, 3 inches off at a time off each one, and making sure that I got it to pulled it tight so the radials were 3 feet off the ground. The whole length of the bottom was 3 feet off the ground, and eventually you come to something you're reasonably happy with. And it doesn't really matter because as long as the measured impedance, which you can measure as well, is more or less right, it's got to be because there's no tuner on the radial on the QCX. It's really important because otherwise you can fry it.
Did you? One last question, at least for now. Did you notice a difference in your VNA ratings when you swept the antenna in your backyard versus the one up at the campsite?
Well, yeah. Things change. It doesn't. It's in my backyard. I got trees all around. You can't even see the top of the mast. I had to lie on the ground to see if I could even see the top of the mast in my backyard. But you can't. The trees are just all around it. So it was a bit different. Not all that much different, but I had to when I put it up. I set it up in the backyard and got the thing where I wanted it to be. Then I took it up to the campground and set it up, and the lengths, things were different. The lengths were I had to adjust the radials to get it right. And excuse me, that's probably the trees around, fair amount of open space where I set it up, as opposed to the backyard. It was sort of crowded. So I did have to adjust it.
Okay. All right. Thanks, Michael.
Yeah.
I think I saw Drew up.
Yeah, very interesting. I didn't get the vertical orientation to start with, but I was wondering, when you were choosing segments, lengths, and number of segments, this is the part that always got me with Easy Neck and Neck 2. How did you alter the number of segments that you had and get different answers?
I did not do that. I didn't bother. You look at Ralph Gable, who has a YouTube channel called Electronics for the Inquisitive Experimenter. He started out with an 80-meter dipole, and he had 60 or 70 segments or something, and on each leg of the dipole. And I just basically I took what Paul Egan was the one that did the design, the original design, with another program called MMAGAL. Not sure what that stands for. This is equivalent of 4NEC2. And he had decided on 20 segments for the vertical piece and 9 for the radial. So I didn't play with it. I just left it.
Yeah, I just wondered. That was always the part that got me, was how to do the segments. But that was a good presentation.
There is somewhere I found when I was looking at this, there's a formula that the segments have to be no longer than X or no shorter than X. I think it's longer.
Okay.
So there's some empirical rules about how to do that, I think.
Well, I shudder to think what the manual looks like. So I'll take your advice and stick to, for 40 meters, we'll stick to 20 segments. Thank you, Michael. It was very good.
Yeah. Okay. Are you building a vertical antenna then, Drew?
Well, no. One of the fellows down here was playing around with an end-fed half-wave, and someone commented to him. I don't know how this all transpired, but anyways, he ended up making a loop on the business end of the 49-to-1 Ballon transformer.
Oh, yeah.
And he put about a 33-foot counterpoise on it, and it is absolutely performing tremendously on 20 meters. Although it's a 66-foot chunk of wire that he made into a loop. And so I was intrigued. He's had the fellow that suggested it, or someone else, did model it, and it's not supposed to work. And it is working extraordinarily well. And we're kind of scratching our heads over how this thing is working. And I thought, well, if it isn't too terribly hard to do, maybe we'll fire it into this thing and see what it says. But anyways, that's what got me going on it. I have tried Easy Neck a couple of times, and I really didn't know what I was doing, and it became obvious very quickly that I probably needed to know a lot more before I got going. I remember the days when it was ported over into something easier to use than the old command line program.
Oh, yeah.
And that's how long ago this was. And it was just, I didn't know what I was doing, and it showed. So now that I've got more time in my hands, I thought I'd go in and play around with it, because Gary's antenna has really intrigued me. I like end feds, and the counterpoise is always a question. I actually bought a current meter so that I could see the effect of the counterpoise as you roll it out and see what the current change is.
Oh yeah.
Well, just a clamp-on radio current meter, yeah.
Well, I started out thinking about doing an end fed, half-wave end fed, and one of the guys in the club, or who was in the club, lent me a couple of end fed antennas. I was actually going to use one. It has a matching thing that allows you to just do a single band antenna, but I never got around to doing it. But basically, what I would have to do with the lengths involved, I would have to have a piece 30 odd feet high, and then the other end of the end fed would have to go out somewhere. So it's just not practical for me with a mast, and this works fine, so I'm happy.
Yeah, well, actually, Dave EAC down here swears by what you've got. He had one set up years ago in Wisconsin for Aries. He brought it out to a field day once with us, and he set the thing up, and it was a great, huge vertical. I don't recall the how many radials he had, but he was on his Electcraft, and he was banging out, doing very, very well with it.
Well, Daniel and I are thinking, V3 and I are thinking, maybe we can do something on 80 meters with my vertical antenna. You'd have to put a coil on it, a matching coil to get the length right on the vertical piece, and the two radials would be huge probably, but or maybe change the coils, but do it that way. But we haven't done that yet.
As I recall, Dave had spirally wound the antenna lead, the antenna itself around a set of the 2-inch fiberglass masts that people were buying at Princess Auto years ago.
Oh yeah.
Anyways, he spirally wound it around that, and that might be a way to get 80 meters onto the size of your. I don't know if your spider pole would take that, but
it'd have to be small wire. That's the other thing. You really, yeah. I don't know that you could use this on 100 watts on this stuff. I don't know.
No, I don't think so. Anyways, that was a great. You really got me thinking again. It was a very good presentation. Thank you.
Well, thanks. Okay, it helps when somebody else knows what you're doing. Can help you.
Well, yeah, I'm thinking maybe I'm going to be visiting Dr. YouTube for a while.
Yeah.
Okay.
Any other?
Go ahead, Howard. Howard? If you're talking, you're muted. Howard? Okay. Okay, go ahead, Pete.
Yeah, I'm just wondering, and what were the results, Michael? How many QSOs did you make, and what kind of where did you make them? Where were they?
You don't want to know.
Well, okay, tell me. Lie then.
Oh, 100. No, I made 2. That's all. I was too embarrassed with my lousy CW. That's a project for the winter.
Where were the 2?
Ohio, I think, was one of them. They were POTUS stations. One of them was Ohio. I don't remember where the other one was. Not all that very far away, but good enough to show it works,
Yeah.
I was really surprised that I can get, a couple hundred miles away, really, on less than 5 watts.
Why did you go to elevated radios?
Oh, because that way there's only 2, and I had for field day. This is going back 4 or 5 years now, at least. I used to do a 40 meter CW, and I started with just elevated dipole. I had a 33-foot mast at the time, and so I just did radials, sort of elevated radial. Just straight dipole, inverted V type dipole, and then I found, we talked to Ed, what you do is you take the quarter wave vertical is 39 feet. But what you can do is you can go say 29 feet up your mast, or 20 feet up your mast with a number 14 wire, and then you'd use a 450 ohm ladder line to get the rest of the length. And what you do is if you need an extra 10 feet, what you do is you have one piece of 5-foot ladder line, and you join it at the very top, the two conductors at the top, and now you've got a single length that's I'm going to get out of the sharing here, a single length that is the right length. And I just used again the elevated radials 3 feet off the ground. That's all I did. Did that answer the question? I hope. I think I answered the question. Did I?
Yeah.
Yeah. Okay. Yeah.
You said you had the ladder line at the top.
Yeah. Yeah. The overall length is 39 feet for the vertical piece, and you get to it by having, let's say, 20 feet from the bottom of the antenna, the 3 feet off the ground, up 20 feet, and then you attach one side of this piece of ladder line that's all together. The length of the ladder line is 10 feet, but there's two segments of 10 feet, which gets you another 20 feet altogether. You have to look at the overall length.
So how did you support that at the top?
What I did, I had a 33-foot mast, and I guided at 2 points up. I forget how, probably one third of the way up and another third, 2/3 of the way up, basically with a little wooden ring that I tied 3 ropes to and supported it that way. That's to prevent it from bending over.
Oh, okay.
That's what you're trying to do.
Yeah. Okay. Cherry.
So which company made was that mast?
It's made the brand. Look for Spiderbeam. Spiderbeam verticals. The antenna is actually made by. It's sold by Vibropex. Originally, I think the antenna came from Europe, but it's sold by Vibropex in the States. And the one I bought was a 40 foot. They have a 60-foot mast as well, which really probably would need to be guyed for sure. But the 40-foot one doesn't if the conductors are light enough. And so I bought it from Vibropex. It's not cheap. It was $372 Canadian by the time I got it here. But the elements are you twist them, like you pull one element out and twist it, and it locks into place. You pull the next element out and twist it again. That's how you get it up. Look for Spiderbeam antennas on the web, and you'll see the designs. There's all kinds of them.
Okay, thank you.
I think Kevin used one at Park Field Day one year, didn't you, Kevin? You and Eric, or?
Yeah, no, I did have one. I mean, it worked okay-ish, but I didn't have enough. Like, I only had 4 radials, so it would have been better to have more radials.
Well, yeah, I guess if it's a conventional vertical, you need a whole bunch of radials. This with the elevated ones, you only need the 2.
Oh, okay. Well, I was just looking in the ARRL antenna book, and it was saying that if you go up to, like, if you're having quarter wavelength radials, going up to 16 improves it a lot, improves your radiation resistance. Mm-hmm. But after that, there's not much benefit. But more copper is better, or more wire is better. That's kind of the.
I guess normally an elevated radial.
An elevated is better than on the ground. Yes.
Yeah, elevated radial. If the impedance of a quarter wave is 37 ohms, I think it is. But if you use radials and you slope them a bit, the slope improves the impedance, brings it down closer to 50. Anyway, it worked for field day, and field day I was getting out, I don't know, northeast US, and depending on propagation, towards California at night. I guess it was, if I remember correctly. So they do work. Yeah.
Oh, cool, cool. Do you still have another question, Cherry?
No, that was all. Thanks.
Okay, because you're done. Okay. Anybody else with a question or comment? No, it looks like that's it. Okay, Michael, that was very good. If I remember correctly, NC2 is free now, isn't it?
For the program NEC apparently is free. For NEC2 has always been free. The full-fledged NEC program was, I forget, I don't know how much it was, but it was, they decided to make it free. So
Yeah,
you can get that one.
yeah, he didn't want to work on the software anymore. That's why he made it free. That's what I read, anyways.
Mm-hmm.
Okay, go ahead, Pete.
No, I think the 4NEC is free now because he retired.
Yeah.
And,
Yeah.
I'm just Googling now. 4NEC is completely free. NEC2, NEC4. I think it's free.
Yeah. Cool. All right. Anybody else before we end discussion? I guess that's it. Thanks, Michael. That was good. Very good.
Oh, you're welcome.
How much time do you think you spent on NEC2 to learn it?
A lot.
Yeah. Yeah. Yeah.
You learn by playing with it, and but what's really gratifying is to see what the model says works.
Yeah.
For real,
Cool. All right. Again, thank you. Okay, so does anybody have any questions, any concerns, any suggestions, anything whatsoever? Just go right ahead. I have something though I want to ask Charlie. Hey, Charlie? I think it was back in the summer I was asking you your NFED random wire setup, and I think I had asked you what your counterpoise length was. Do you remember what it is?
I'm not actually using a counterpoise per se. I'm using the outside of the coax runs down about 20 feet or so before it goes into an ugly ballon, and that 20-ish feet of coax, the outside of it, is behaving as a counterpoise for it.
Oh, okay, okay. That makes sense. That makes sense. Yeah, because if I use the ugly ballon, well, I've used it in the past, but I had it right at the base, and then I would run a piece of wire out.
Yeah, it won't do much for you right at the base.
Yeah.
But I run out about from where I have the transformer. I go out about 20 feet or so, and then I've got maybe 20 or 25 feet of coax coiled in kind of a loose coil, about 14, 16 inches in diameter, lying on the ground with a board across the top of it, and that extra capacitance to the ground seems to help as well.
No, okay. I'll have to think about that. Try it out, maybe. So, again, any questions, any suggestions, any concerns? Go ahead, Pete.
I was going to ask, well, at great risk, I was going to ask Kevin and, well, at least Eric, what's going on up at Quebec City that grabbed their interest? I know it's a hacker thing, but what is it that's going on up there?
It's a cybersecurity conference. Otherwise, go to hackfest.ca. That's the website.
In other words, our computers will be secure as yours will all be hacked. You want to own all our computers right now, Kevin, or
No, we'll wait.
all right, tomorrow. Well, we're going to something called beginner CTF, which stands for capture the flag. So that's what we're here to learn all about, is, how to, like basically grab disk images from Jitsi user connections and mount them onto our system, and then, inject the code back into your system. So as long as you're connected to the Jitsi.
And we're going to mess up your antenna models.
Sorry I even asked, guys. I apologize profusely.
Cheers.
Don't forget, I know where you guys live.
Oh, please, and bring your laptop.
He won't need to. We'll get it from here.
That's true. Yeah, don't bother bringing your laptop.
I'll turn
We've
off the
already got
Wi-Fi and the internet.
Doesn't matter.
Go ahead, Drew.
If those guys are up at the Capture the Flag beginners course, you guys heading for Las Vegas next time?
Yeah,
I know this one. I know guys in this world. They spend a lot of time hacking each other in the off hours.
Right. Yeah, I'm sure that's part of it.
Precautions have been taken, Drew. Don't worry.
So you turned it off.
Well, you're sharing a room, Drew. Come on.
The silly thing is that Kevin has got his unlocked laptop in front of me right now, so I just gotta go to the bathroom. Hang on. Did I ever tell you that Dave did that? We were sitting side by side at a park buildathon many years ago, and the guy who is like CISSP certified and all of that walked away, and his laptop was just open. So, I helped myself to his GitHub page, changed his profile, made him look like Rick Astley for a few weeks until somebody noticed. So anyway, security professional, huh?
Yeah.
And then he said, Eric, it's all about trust. It's all about trust.
You need to do a presentation on this, gentlemen.
Yeah, anyway, just here to learn. That's all. So, and first time in La Belle, well, not in Quebec City for both of us for about a quarter of a century. So looking forward to some poutine at La Belle Province restaurant on the way back in Drummondville. But anyway, if there's anything, if anybody knows of anything we should check out in particular in Quebec City, we're all ears. We have a few hours tomorrow of freedom. So
yeah,
if there's anything on the in the Geek Atlas or whatever.
No,
there's a long deck at the old port. Just keep on walking.
Oh, that's not nice. Although we weren't with you either, so fair, touche.
Let's see if we can hack our laptops or our computers from the bottom of the lake. Frank, go ahead.
Yeah, I have a quick question for Michael. In watching you here, I notice that you have several what appear to be DXCC certificates around the top of the room. I was wondering if you could just explain how you managed to get all of those when I worked my ass off and I only have one.
Well, I don't know. I have 319 country DXCC confirmed. I've got DXCC on all the bands except 80. I've got 91 on 80, which is one of the reasons I want to set up an 80-meter antenna. But just 30 odd years of chasing DX, I guess. Looking, that's just what I did. And I have. I started with an R7 vertical that's sitting at the roof line of my 2-story place. And now I've got a 3-element mini quad at 39 feet on a tower. So that's what I do.
Are they all CW?
No. No. I think I've got. I have to look. It's a couple hundred CW, but not all of them. No.
Well, congratulations.
Well, thanks.
I'm impressed.
Daniel's got me beat.
Oh, really?
Daniel's got Bouvet Island, which I don't have, unfortunately. Maybe this coming year. We'll see.
Well, good luck on that.
Yeah, thanks.
Cherry, go ahead.
So you asked a question, Frank, which I always wanted to ask Michael. So seems like your wall is all full with that certificates, right? Like you can build your furniture with that.
Probably, yeah.
So very highly impressive. Like I always wondered, like how you got so many of them, like decorated all around your room. Yeah, that's great, impressive work. Like 30 years, you said. So that's a lot of hobby up there. Peter is showing now.
Well, I got my license in 1992. Is that right? Yeah, 1992, January 92.
Cool.
And I've been beavering away ever since. So
it's because you're collecting DX contacts and not collecting parts like I am.
Yeah, right. Well, I do have some parts for the audio amplifier, by the way. I did get some, so getting there.
We'll talk this week or next week.
Yeah.
Okay. I guess we're going to save the round table for the mixer. Yeah. Okay.
Yeah, let's do that.
Yeah. Okay. I had talked to Peter earlier on doing a little presentation tonight, but we're going to hold off. I don't know if you guys remember that video that Dave posted where I am testing the QRP labs with the DCR, and you could clearly hear that it isn't matching, so the signal was bad. Well, I've got a second video that's going to go up when Dave gets back. I was able to modify the QRP Labs filter to work with the DCR, and it was very, very simple. But I'm going to do a presentation on it, the next mixer coming up. But when Dave gets back, I'll get the video put up. And
yeah, I put you down for the next meeting on that one, Ken. And that meeting I'll do as well, a short one on LT Spice analysis types.
Yeah.
And then you've got the QRP Labs filter, yes.
Yes, that's November 5th.
Next month.
Yeah, November 5th. But very easy to do. It takes less than 5 minutes to modify the filters, and they will work with all the QRP Labs filters. But I'll save the mod for the presentation. Anybody else have anything they want to discuss or suggest or anything at all?
I could say, we've pretty much, I think we've got our schedule of presentation for the rest of the year filled. I'm not sure. There might be one day open. I'm not sure, but I think Dave might fill in there. So if anybody wants to start thinking about presentations in 2026, let me know. Pick a subject you want to learn about and do a little presentation on it. But let me know. I know I'm bugging you guys earlier, I guess, for 2026, but what the heck? Why not start thinking about it now? That's it for me, Ken.
Yeah, it's actually me. Bob, are you on the line? Bob, you there?
If you're talking, Bob, you're muted.
Yeah, maybe he's left his chair.
Possibly.
Just so I'm not duplicating things in case I missed something at the beginning. Did he mention anything about Dwayne?
He didn't mention anything about him on here, but he did send me an email the other day saying that Dwayne had passed on in July.
What?
Okay, right.
That was it.
Yeah, sorry about that.
Oh, hi, Bob.
Yeah.
Yeah. Sorry, I was in the other
Yeah.
room. Yes, he did. Yeah, as I said, he passed away in July. I had just our QRP club was just, we were trying to see if we can get him active again, and last week I had a meeting with one of the guys, and we dreamed up a project, and I was trying to email him and text him, and it kept bouncing back, and I was going down in that direction today or yesterday, and I said, well, on my way back today, I'd stopped, by his place today because I passed it on the way home, and then I kept checking, and I saw something that had an obituary, and then I found the funeral home, and I looked it up, and he passed away, and he was cremated. So that's about all I know. I think I said before he had a stroke after. I think Peter asked about him, and I came back from um, Orlando, and I stopped by his place, and he had a stroke, but he was like recovering, and he said that he can't use his hands well, but he's been reading, and he's been theorizing, and was going to start designing, and that was a project. That's when our club said, "Oh, let's find something for him to design." So that's about it. He's a big loss to our club. He's one of the two. He's one of the two guys that did the most inventing for the North Georgia QRP Club, and was a real inspiration to me. He got me into 3D printing and PIC controllers and Arduinos, and I still have a couple of his projects in boxes somewhere that I've never finished building, that I was going to ask him to help me with. So that's about it. He was all.
Yeah, that's really weird because I think the last meeting I was here was there. I missed whatever. I can't remember what it was, but you were on, Bob, and I had mentioned I was thinking about asking you if you had heard from Dwayne, and I forgot all about it. And then just the other day, I think it was.
The extra info there, Bobby, was just all we came across a couple meetings ago when you weren't present. Was I just on a whim decided to Google his name, and I was like, uh-oh. So thanks for the extra info there. That was nice.
Okay, I hate to be the bearer of bad news.
Yeah.
Yeah.
Okay, appreciate it. Nonetheless.
Have you been in contact with any of his family?
No, I had only met his wife. His daughter is in Wisconsin. I think his daughter's in Wisconsin. I don't know where the son is.
Okay. I was just curious.
Sorry,
Alrighty.
what is his call sign again?
Kilo.
KB4
KV4Q
V.
QV.
Yeah.
No, Q. Oh, I just had it.
I think it's Quebec Victor Bravo, I believe.
Oh, it's a 2-letter call, isn't it?
Yeah, that sounds familiar.
KV. Yeah, KV. Yeah, Victor Bravo. Okay. KQ4VB. KQ4 Victor Bravo. Or maybe
Close.
Q is at the end.
Okay, thanks.
That's too bad. Too bad. It was great having him in the meetings, and he would talk about some of his projects and everything, and that's too bad.
We ran into him at Hamvention. That's where we first made contact, of course. Yeah.
Wow. Okay. Well, like I said, you'll be missed. Um. So, does anybody have anything else we want to discuss or anything? Shall we call it an evening?
Sure.
Okay, gentlemen. Good meeting. Short but sweet. Uh, and the next meeting is November the 5th. That will be the mixer And yeah, there's a couple of presentations lined up for that. Okay, gentlemen, have a good evening and have a good weekend. And we'll see you later.
Thanks, Ken.
Yeah,
Thank
enjoy
you.
Quebec City, you
Have
hackers.
you it all.
Thanks.
Bye
Never been